Here we go. Thank you.
All right, thank you very much. Hello, everyone. I'll be presenting on beginner-friendly shader programming in p5.js version 2. This is a work in progress. And if you saw the abstract of this talk, you might have seen a code snippet. We actually had a code snippet for a small shader, and that's the basis of what you see here. So the talk, everything in the background of each slide is a running p5.js sketch. p5.js is a JavaScript library that I'll briefly introduce. I'll introduce what's happening in the version 2. And occasionally I'll have code examples that I'll walk through. But whether or not you've ever used p5, or if you ever want to use p5, or in fact not at all, I think everyone here who is working with either creative code or computer creativity tools in general, I would like to offer the question to you of when you see the phrase beginner friendly, what does that actually mean? How do you operationalize that within your work, either as a creator or as a programmer? And I'll offer one particular definition of that we use, and maybe that could be an interesting start of a conversation at some point. So in this particular sketch, what I want to point out is that the shader definition here is less than 10 lines. We create the shader in a setup call. So every P5 program has a setup part and a draw part. Then we define it in several lines. This is very similar to what's in the abstract, but it just has slightly more colors. And then we apply it. And then it acts as a little brush. What is p5.js? Oh, and I'm presenting this on behalf of my colleagues who are p5.js contributors and maintainers. So Dave, Luke, Perminder, and Ken were extremely important in the development of this feature and of version 2 generally. And I'm Kit. I'm the current p5.js project lead at Processing Foundation. And p5.js is many things, but it is a JavaScript library for making art and learning to code. It's community driven. It has adopted in 2019 an access and inclusion statement. So it prioritizes features that increase access and inclusion as their kind of primary goal. And right now, what I'm going to talk about is making coding beginner friendly, specifically by requiring as little prior knowledge as possible to get hands-on. So on the left, you're going to see the code for this sketch, which creates a canvas object. It colors the background pink. It defines how the painting will, like whether there will be a stroke or a fill. It provides a description to a screen reader. So if a screen reader encounters this canvas element in a web page, it will receive a textual description. And in the draw loop at every 60 times per second, it draws a circle at the location of the mouse and the X and Y coordinate. And this is a example sketch that's often part of like it's a part of our README file. It's often part of a starting point as it's like the smallest kind of hello world example. And something that's interesting to point out here is that right now, this is a renderer that uses the Canvas API, and you can, of course, draw the circle in Canvas API. But to draw a circle in Canvas API, you use the arc function, and you have to parameterize it in a way that requires knowing what an angle is. A fourth grader is fully capable of understanding to draw a circle at the mouse, and a teacher of many different disciplines can very well explain what that means and how to do algorithmic art. But the barrier that is lowered by having a direct circle call is kind of part of what I'm going to talk about with beginner friendliness. Nobody involved in that situation has to know about arcs, trigonometry, or angles to any degree. So for the last few years, as part of p5.js 2.0, we've been working on a new API for writing shaders. And so this talk is going to be about that, which is a very specific part of p5.js. And our goal is a beginner-friendly creative coding experience that builds on the syntactic and conceptual vocabulary of p5.js that is already familiar to learners, to educators, and to artists. And when we talk about beginner friendliness as a goal, the two things that I want to point out is flexibility and expressiveness from the start of the learning journey. In particular, it's a learning journey that does not start in the computer course or in a computer lab. So outside of a context where you can assume mathematic knowledge or other forms of computer science knowledge. As well as empowering educators who are teaching in disciplines outside of computer graphics to be able to incorporate algorithmic art effectively into their teaching and to feel confident doing that. So we actually have some presentations at SIGGRAPH this year that will present work both from last year's fellow work, this is from fellowship last year that was done in partnership with members of the Arts for Healing and Justice Network to bring creative coding resources to justice-impacted youth. And you can read more about that both on the impact report and on talks from last year. So and the other part that I mentioned is that a lot of what's really important about p5.js development is building in community. It was initiated in 2013 by Lauren Lee McCarthy, and the 2.0 project in particular has been ongoing, starting with community requests for features, for feedback, and so on in 2023. So we released last year. Right now, it's about 3 days away from the anniversary. Actually, after the anniversary, so we're like one year and 3 days old since the 2.0 release. And we're currently working on the 2.3 milestone. And during this time from 2013, over 800 people contributed to code, ideas, documentation, and many aspects of p5.js. So it's a pretty extensive project. For the version 2, development and documentation has been supported by the Generative Art Foundation, by Butter, and in 2023 and 2024 by the Sovereign Tech Fund, and always extensively through donations to the Processing Foundation. So I started out by showing you some shader code. And what I'm going to go into next is some more examples, but what I showed had this pattern to it. I showed something that included pixel inputs that worked with material shader. It had a point where a shader was defined. There's some user-defined behavior. It was built, and then it was invoked or applied in the draw loop. And so one thing that I wanted to point out about this is the general structure will be similar to this, and I'll say it again in the next section, which is users of this feature are not defining an entire graphics pipeline and do not need to know anything about graphics pipelines to get started. What it's doing is it has a default pipeline that is being modified through hooks. So in the definition of like my shader builder here, there are hooks for doing particular things, for working, for example, with filters, which is going to be the next subject. So now you can see a little bit of a blur. And from a pedagogical point, it's interesting to point out that there are built-in shaders whether or not a user might be aware of them. So for example, the built-in blur, which is implemented in GLSL, applies a blur filter over a video feed. So in this case, I'm using my camera. And I can apply this filter. And GLSL shaders have been supported since version 1, since a while, and you can have a really interesting user-defined shaders that you can pass in through providing the code and then creating the shader. What does the same code look like with strands? So it's the same pattern of there is some definition here that uses the hooks from p5 strands. There's an application, and here, rather than create filter shader, there's a build filter shader that that takes the default pipeline and modifies it with the hooks as the user defines. So in this case, I have filter color begin and end, which if you use p5.js, there is this pattern of begin and end. And if you don't, that might be a little bit unusual, but there's also other ways to define these shaders. You can also define it in a function. But this is an example of an API decision that we made in order to make this more familiar to p5.js users while scaffolding learning kind of more advanced concepts of shader programming. So the way that we've approached this testing and API feedback process is through documentation and API updates that were driven by contributor feedback. What does this mean? Is that we are now hosting like regular developer chats on Discord, where we've had various artists and educators try this tool out and give feedback. And until now, so since the release of 2.0 until now, there's more than 20 people who have contributed substantively both to the code and to the documentation. Let's see. So far, I've talked a little bit about, I've given an example of pixel inputs and material shader on the first slide, and I've given an example of like the filter shader. I've given a filter shader example that uses the filter color hook, the filter to apply, which is sort of similar to filter blur, but this way you can create a user-defined shader. And as I'm not going to go into the details of each individual like type of shader or different hooks, but if you're interested in that, I am hosting a kind of hackathon workshop tomorrow. Because this is still work in progress. There's still ongoing work, so I will also talk about that. But if you want to try it out, I'll give an introduction tomorrow for the first hour of that. So before I go into what's next for the next minor release, which is an experimental computer shader support, I'm going to go through step by step of how do we envision shader programming being relevant to p5.js users or learners. So this is an example that's not using any shaders. This is from the examples library. It uses for loops to implement Conway's game of life. So each individual cell decides whether it lives or dies based on how many neighbors it has. Either it gets crowded or it gets spawned. So it's an example of emergent behavior and for an emergent system where you have very few rules that govern individual cells that then create these kind of patterns that seem compelling on the whole. So this, I don't think you can see that, but I see it for my own demo debugging purposes. There's an FPS marker at the top right. The FPS here is 10. I can make it higher. I'm not going to, but it would work. However, if I make the cell size smaller, that is going to take it down to FPS of 5, and that's just an artifact of the fact that this is implemented using a for loop. So it's going through iteratively and calculating all these rules. All right, well, we can definitely do better than that. We can use a parallel logic. So this is an implementation of the game of life pixel by pixel, and it's using the filter shader, so the same kind of code that I showed a moment ago. So filter color, begin, end, get texture, except that the logic here has to do with implementing this neighbor counting mechanism. So there's some interesting kind of aspects of this, and this was developed during, or this was iterated upon during one of these Discord calls with the community and with the current contributors as a way to kind of see, can we use this tool to implement some of the established examples? Besides making it possible to take something that already exists in a different form and making it a little bit more performant, a little bit higher resolution, a little bit faster, because this is running at 60 FPS and it's all right, though probably it wouldn't be on every device, so there's definitely still a lot of room for improvement. It offers kind of new possibilities for what creatively is possible because of kind of where in the graphics approach, you're actually like applying this logic. So because this is applied as a filter, it can do some interesting things when I draw my circle again. So this is the same circle from the beginning of the talk where I'm just following the mouse. But because of the way that this filter implements game of life, it becomes interactive in an interesting way. And we're excited to see kind of what creative possibilities can arise from students meeting that or from teachers meeting that. And so this is all that's currently live. So this is all using version 2. So if you copy this code, then it would work. And now I'm going to show you some stuff that only exists in an experimental build. So this is not currently live. This is a preview. So this is part of the planned 2.3 release, which would include experimental support for compute shaders. So in this case, it runs much faster. And all of these examples, I, for example, had to set pixel density to 1 to account for the retina display. But if I removed it from the previous examples, it would not be at a 60 FPS. But this one still would be. So if I remove it, you can later on walk up and confirm that in fact it is 60 FPS. But more importantly, it kind of supports other ways of like other possibilities for what you can do with this particular tooling. Like, for example, you can use it for state management. You could support like prototyping games in the way that you couldn't necessarily with kind of the filter shader approach, which does work for the game of life, but isn't generalizable to other more complex cases. So I've tried to offer to you an example of how we've been approaching beginner friendliness. And so I'm just going to zoom out and recap that. So our goal generally, oh, sorry. I wanted to find a different slide, but actually it's here. What I wanted to show was this just now, but there it is. It's a demo. I ran that risk. So when we talk about making the shaders kind of beginner friendly, it comes back to that question of which prerequisites are actually necessary. And so when we approach that, we talk about like, how do we scaffold learning from no prerequisites at all to learning things that gradually make you more familiar with shader programming more generally. So to get started on all of the examples, you don't need to know anything about the shader pipeline or uniforms or approaching parallel computation, but the goal is hopefully you learn those things along the way. And so again, this is for flexibility and extensibility to start with, and empowering educators that are teaching in other disciplines moving on. So here in this kind of scaffold, I've started with level 0, which is recognizing the built-in features as shaders. So this is the filter blur being a shader. After that, the only prerequisites of JavaScript and p5.js are to make and update variables or to create functions, which are prerequisites, but they are not prerequisites that have to do with complex graphics pipelines. And one of the main thing I wanted to point out here is that since the beginning of this feature, when we first released it in a year ago, you actually had to use uniforms quite early on in order to bring information like the mouse position or timing, and to animate things, you had to bring that in with uniforms. But by implementing at the P5 level, the different built-ins that people would expect in a regular P5 sketch, so that's mouse X, mouse Y, like frame count, these things, they can be used inside hooks without people realizing that they're passing that information in. So we've kind of intentionally moved the requirement of uniforms from the very beginning until much, much later. So it's entirely possible to build the kinds of examples that I was showing earlier on without any use of uniforms. Okay. Now I'll go back to this. Good. So coming back to the original sketch that I showed you, we have the example of changing the RGB values per pixel. And here you can see that there's noise calculation, there's an animation that's happening by using the millis function, and these are built in. So this is an example of something that would have used in uniform when we first released it in 2.0, but now does not. Now this is almost a liner, or something like noise. There's also an ongoing implementation of random for a similar kind of natural progression from how it feels to write a P5 sketch to how it feels to write this JavaScript inside a Strand's shader definition. What happens underneath is a transpilation to GLSL. So something that you might have noticed in the compute example is that here the create canvas says WebGPU, whereas in some of the other examples, it says WebGL. So that's part of, so in supporting the web GPU renderer, we basically also allow people to learn one set of abstractions for and patterns and so on of how to write shaders that are then applicable across different renderers. The web GPU one is available for community testing, but it's definitely still an ongoing work. So with that, I would be very happy to take questions. You can contact me there, or you can join our community on Discord or Discourse. So thanks so much for your attention.
You. Okay. Are there any questions? Everybody's holding back the questions for the workshop tomorrow, yeah? There's one over there.
So how do you measure that?
Which?
Like how beginner friendly something is, how would you measure it? Like how would you quantify it? Like how would you test it with users? I don't have an answer. I'm just curious.
I am delighted by the question because I come from a research background. I was doing quite a lot of data analytics in the past, and I definitely I want to have a much more operationalized and practical and measurable way to approach this. One of the links I included there was at some point in the talk was the Processing Foundation Impact Report. There we cite a survey from teachers who attended the Art Plus Code camp. So these are teachers primarily not in computer science who teach, who learn how to teach P5. So we have a survey of those. We have a short presentation at SIGGRAPH about it. We're going to expand the kind of the surveying that we do for like the educators that are then learning P5. So for the second half of that, that's kind of so far the self-reported measurement. I think that it could be, there are many other possibilities, but that is a starting point. And in terms of the first one, which is the accessibility and flexibility and so on, we've always looked to qualitative measures and as well as to the various community surveys. And I think that there's a lot of room for growth there, but those are like the two things that you notice is when a student says, I didn't think that this was for me. I didn't think that I would be into computers, and I'm into computers. Like, I think that's the success metric for, is it beginner friendly to somebody who is not actually a beginner? Because if you're already at the computer, if you already have all this background knowledge, then you are a beginner to a particular tool, but you are not a beginner to the concept. And that kind of is a harder line to manage. Yeah.